All right, welcome to the exam 3 review. So this will be given on the Friday of week 13. Same exact format as the previous two, 8 true false, 8 multiple choice for problem solving. Same basic way it's going to be treated. Goes live Friday at noon, closes midnight on Saturday. Closed notes, closed internet, individual equation sheet will be provided, and you can use a one-page equation sheet of your own that you have made. So as we've moved through the exam here, we are now at the point where we are technically kind of moving into the end portion here. So you will see phasors on the exam. We technically also with the RC circuit and the RL circuit are looking at a first order circuit. We haven't explicitly called it that, but that is what those are classified as. So you will see RC and RL on the exam. So for chapter 11, this is where we introduce the alternating current, it's alternating current and alternating voltage sources. So please understand the difference between RMS, average, and peak and being able to convert between them. This is where we also introduced the phasor. We didn't really use it until the RC circuit at the end. The last couple of lectures we've talked about. Again, typically it gets a little bit more important when we get to RLC circuit, so that will most likely be in the conceptual only part. I haven't finished writing the exam, so I'm not 100% sure exactly where it's going to be yet, but I would study it. The phase shift stuff, so for the AC source, where we have our equation with A sine omega t plus phi, the phi part stuff will be the conceptual part only. We will, for this exam, only be looking at sinusoidal waveforms. With that, oh, sorry, I put this in the wrong. Capacitors is the next one. I put this on the wrong slide. So types of capacitors for chapter 12, we won't need to study. So for chapter 12, again, ignore the types of capacitors as well as the energy stored in a capacitor, but study capacitors in series and parallel, charging, discharging in DC and AC circuits. So for AC, the reactance value, so that XC value, be able to calculate it. We didn't really use it for this chapter very much, but when we came back to it in chapter 15, that was where it was more useful. In the conceptual part, that will be where you have calculating capacitance. So that is the C is equal, what is it? Epsilon A over D. I feel like I'm missing a term in there. Oh, Q epsilon A over D, I think, is the equation. Conceptual part only. Same thing is going to be true with leakage. So you will probably have a question similar to exam 1 with resistors, where we needed to find a total resistance value and then find the voltage or the current. This time you'll probably need to find a total capacitance for a series and parallel combination circuit. Go through and look at that. For charging and discharging, this will be something that we have for the RL circuit. More so probably for chapter 15 stuff, but again, that is totally possible to be on there. For chapter 13, this was our inductor chapter, so kind of similar format to chapter 12 and what you should and shouldn't study. So inductors in series and parallel, so be able to find the equivalent inductance. The increasing and decreasing current equations, AC and DC sources, and the reactance. Again, for this one here, reactance and the AC source are probably going to be in the conceptual part only. Not guaranteed, but most likely, because we haven't talked about the LR circuit in its entirety at this time. Most likely going to be in the conceptual only part for the final exam. you could expect a problem-solving question there. So for the conceptual only part, calculating the inductance, so that is calculating the L value, so that has to do with the number of coils, the length, the mu value, and so on. The winding resistance and capacitance, as well as Lenz's law, will be conceptual only. You can completely ignore the energy stored in an inductor, as well as the different types of inductors. So for the capacitor and the inductor, I'm just going to use the basic symbol for all of them. So for the parallel plate capacitor, the two parallel lines, that's it. And then for the inductors, just the coil, regardless. We then skip to chapter 15 here. So this was the RC circuit chapter that we covered in week 12. So be able to utilize the complex plane, understand rectangular and polar form. You will be asked to convert between them. Be able to do the impedance of RC circuits in series and parallel. So you will, similar to the last question that we saw for lecture 24, where we needed to find the total impedance value, that is something you'll need to be able to do. You will not need to go through and find the charge or the voltage or anything like that. Just calculating the total impedance of an RC circuit, that is a problem-solving question on the exam. So if we think about it here, 4 chapters, 4 problem-solving questions. In reality, chapter 11, so the AC stuff, is probably combined with something else. Probably something where we only saw, right, to use impedance, we need to have an AC source, so probably here. So this will be a little heavier on the capacitors in comparison to the inductors, if you understand what I mean. But yeah, if you have any questions about exam 3, please be sure to ask.